Good morning, students. This is K. Veranelu, Electrical Department. Now, this semester 2 by 1, I am going to handle the subject EMF, Electromagnetic Fields. Electromagnetic Fields, in shortcut form, EMF. Okay, so this book author is Sadiq. Publication Oxford. If you want to purchase one more author, Adver Singh Pearson Publications. If anybody wants to interest, you can purchase any one book, no problem. Okay. So before to start my class, first you are entering into the core this semester only. The first year entirely it is only basics. Okay. Now this year onwards entire core subjects will be started. Each and every subject is very important to write any competitive exams. Okay, please more concentrate on subjects. Okay, then only we can reach our goals and we have more marks secure in semester examinations, otherwise any competitive examinations also. Okay, okay, now see, now coming to the subject, it is a electromagnetic fields. The field is comprises for the two parameters, that is an electro and magnetic. Electric field is separate and magnetic field is separate. This by combination of those two parts, electric field as well as an magnetic field, you have to study. That is our subject. Electric field is completely different and magnetic field is completely different, but the concept is the same, just we are changing the letters or parameters. Once if you are perfect of this electric field, then we can similar way you can write it for magnetic field. Okay, electric field and magnetic field. A simple example for electric field. Electric name only indicate just where uses the charges positive or negative polarities, that is an electric. Take your mobile phone battery, the best example. The battery is consisting of the signs positive and a negative backside of this battery, so that is belongs to an electric charge. Whereas magnetic, in place of an that polarity is positive and negative, just replace that north and south polarities. The remaining the process as it is that of an electric field is the same as that of an magnetic field, just we are changing that the signs. If you are placing for positive sign, electric field is an indicator n north pole, and if you are indicating for electric field in negative pole, the same will be indicated in south. The remaining operation where we are going to be operation will be existing on particular fields, that is an electric field or magnetic field, the same criteria. Okay, and similar way, this total this subject is consisting of an 5 units. Among that 5 units, 2.5 units is related to electric field, and the remaining 2.5 units is related to magnetic field. If you perfect of this electric field of 200 of unit 2.5 units, then definitely you can go to the this remaining 2.5 units, no doubt at all. If you perfect, then just you are replacing the signs, then positive, negative to north to south, then you can easily will get. Okay, so uh, coming to our subject, first we will discuss about some basic parameters to requirements of an electric and magnetic fields. Some basic parameters. The basic parameter is that mainly introduce the vector. The main parameter is that basic is, what do you mean by vector? So if you want to clearly understand the vector concept, then first you know the comparison of an scalar and vector, then you can easily understand for the vector quantities. Okay, now comparing the first scalar. Scalar is a only magnitude. Scalar is a only magnitude. There is no direction. Scalar is a magnitude, then particular value. There is no direction. Particular value is an existing. That is, then we can call is called a scalar quantity. The best, when we talk about mass, it is a scalar quantity. The mass, weight of that object, just it will be indicating weight. Like example, 43 kg, 53, 66, 20 kgs. Likewise, just it will be only representing that a magnitude only. When we talk about time, 2:30 p.m., 10 o'clock, 10 a.m. So likewise, these all the quantities are related to scalar quantities. Now coming to vector quantities, these quantities having magnitude and directions. Magnitude and direction. So magnitude already we are discussed in scalar quantity. That is an only, it will be indicating a number, particular number. Whereas direction is going to be an direction also is to be introduced in this vector quantity. What is the example? When you talk about velocity, force, velocity, the rate of change of distance, then particular distance, how much distance, then particular rate. Next, force, how much amount of force is going to moving, then after which direction is taking. Those two are the best examples of the vector. Okay, and next comparison. Scalar quantity is having only one dimension, so it will represents only one dimension, but vector quantities is represents more than directions. Because of and taking best example in mass only, the mass of the object will be represents only one dimension, that particular value 43. Whereas for force or velocity, it will be represents sometimes is going to be vehicle is going to be speed and lower speed, higher speed and medium speed. Automatically the magnitude will be the dimension will be the changes. Okay, and next one, the scalars can be divided with another scalar quantities. Very important one. The scalar quantities can be divided with another scalar quantity, whereas vector quantity cannot be divided with another vector quantities. Scalar quantity is exactly divisible with scalar quantity only. 43 is divided by 43, you will get one scalar quantity. But whereas an vector quantity, it cannot be prescribed, because of an it will be varying continuously. Very important one. Okay, next one, if you want to represent the scalar quantity, magnitude and unit. Magnitude in the sense number, number and unities required to represents the scalar quantities. Number and unit represents the scalar quantities. Next one, while we are representing a vector quantity, it represents number, direction and unit is required represents a vector quantity. Number, direction and unit is required to represent the vector quantity. The best examples of an scalar is that already we are discussed, that is an mass time, whereas best example of an vector quantity is force, velocity. Okay, likewise we can compare both of the things, that is an scalar and vector. Okay, so while you somewhat understanding of these vectors, after that how to represent the vector, we are having one vector value, then how to represent, how to calculate that vector value, how to calculate that unit vector value. Okay, that are the basic needs. These are all the basic needs will be useful for to calculating total electric fields as well as an magnetic fields. Mainly this vector representation in Cartesian form mainly represents vector in Cartesian form. That form is an existing a bar is equal to a suffix x bar plus a suffix y bar plus a suffix z bar, where a is a unit number in the sense magnitude and unit. A x suffix x is a then particular direction, suffix x direction, suffix y direction of unit a and z direction of an unit a. That is a general representation of Cartesian of an vector. If you want to represent that magnitude of vector, just a is equal to under root of a suffix x square plus a suffix y square plus a suffix z square. Just you are taking that root, then you will get result of an that magnitude of the vector. Similarly, calculation of unit vector also. Okay, so these are the major basic things in electromagnetic fields. These are all the points and scalar quantities regarding vector quantities. Then how can you represent this? All the quantities will be very useful to calculation part of an electric field as well as an magnetic field. That vector, that total vector concept only. Just why you are saying I'm scalar quantity here, this and while comparing of this another one, then you can easily understand. That's what I'm going to be taking a difference between that scalar and vector quantities. Vector is very useful all the quantities of an electric field as well as an magnetic field. Okay, this is that introduction about electromagnetic fields. Okay, the remaining section start on tomorrow. Okay, thank you.